Okay, number 13 is a classic wink wink problem that you might see again sometime, wink wink. So this kind of problem, what we're going to do is first factor in, we're going to raise the temperature of our aluminum container plus the water that's inside of it, and then convert some of that water into steam. So first we're going to heat the pot. Aluminum. Q equals mc delta T. Our aluminum Q is going to be the mass of aluminum, 0.750 kilograms, times the heat capacity of aluminum, 900 joules per kilogram, degrees C, times the change in temperature. We're going to take this water in the book problem from 30 degrees, that's our initial temperature, to the boiling point. The boiling point of water is 100 degrees. So 100 degrees Celsius minus 30 degrees Celsius. That's a 70-degree temperature difference. So when I plug in those numbers, the heat that I had to add to the aluminum to make this happen was 47,250 joules. That looks like a big number. Turns out in the fullness of time that's very little. We can ignore that most of the time. Second thing we need to do is heat our water, to 100 degrees Celsius. Water won't boil unless it's at its boiling point, so the first thing we have to do is get it there. QW equals MW CW delta TW. So the mass of water, 2.5 kilograms, times the heat capacity, 4186 joules per kilogram, degrees C. Same 70-degree temperature difference. And this is a much bigger number. Heat that we added to water was 732,550 joules. But wait, there's more. Third, convert 0.750 kilograms of water to steam. Now we're into the latent heat of fusion. Once the water, I said fusion, I meant vaporization. Once the water is at its boiling point, it will vaporize. It'll turn into a gas. It'll stay at 100 degrees Celsius, but in order to turn into a gas, we have to add more heat. Q equals mLV. Now the mass of water that we're talking about here, they said only 0.750 kilograms of the water is converted into steam. And then we're doing that times the latent heat of vaporization, which is 2256 kilojoules per kilogram. So I'm going to get an answer here in kilojoules that I'll then have to convert into joules. The answer in kilojoules is 1692 kilojoules, which is 1692000 joules. 1,692,000 joules, sorry, that we had to add. Okay, we're not done yet even, because now we added this much heat to our aluminum, and then this much heat to heat up the water, and then this much heat to boil some of the water, turn it into steam. I add those numbers together, and I get 2.47 times 10 to the 6 joules total in order to heat up that water and turn it into steam. If I'm adding heat at a rate of 500 joules per second, that means that every 1 second there's 500 joules, right? So that number divided by 500 tells me how many seconds, and I got 4,944 seconds, which has got to be some number of minutes, but I didn't do that math. I did it in seconds. I know that's confusing, but it's important. Learn it. answer questions on it later.